over here is called a tilde. Tilda, tilde. So there are a few things to take note. So a few things to take note. One is if this system had damping. So far we did not include damping, right? So that means it's a damped linear oscillating system. Then there's going to be one more matrix that's going to come in. It's called a damping matrix, D. And not only that, you will have out of the damping together with your velocity matrix, x dot, tilde. And they have to be included. So to give you a sense of how it looks like for D, for example, it can look like C1 plus C2 minus C2 minus C2, C2 plus C3, and then your velocity vector, that is your x dot 1, x dot 2. You're going to expect this inside this equation. Right? So now you only have the mass matrix, you have the spring stiffness matrix. There's no damping matrix. Damping matrix is not included because in the system there's no damper. Had it been that there's damper, then you can expect there is this insertion. So for a purely rotational system, instead of a linearly translating system, what we do is that we replace the M mass matrix by what we call inertia matrix. So we call that inertia matrix I. Right? And sometimes it's called a tensor. Right? This is a name for inertia matrix. So the important part here is that I want to talk about this coordinate coupling. This topic, coordinate coupling. So for multiple degree of freedom system, this equation of motion are coupled. And what does coupling mean? It means that the equations are dependent on one another. So how do we see if the system is it coupled? There are two things to look at. One is your dynamically coupled system. And what it means is that the off diagonal of the M matrix must not be equal to 0. So what's off diagonal? You can see that the M matrix, M1, 0, 0, M2, this is what we call off diagonal. Off diagonal. So if it's equal to 0, that means it's dynamically uncoupled. If it's not equal to 0, that means dynamically coupled. And dynamically coupled means that the equations are dependent on one another. So there's also the other part, statically coupled. So you got to see this kind of definition, this kind of words here. So off diagonal for the K matrix must not be equal to 0. If it's equal to 0, that means it's statically uncoupled. So for the above system, so those are definitions. If I look at the above system, it is statically coupled statically coupled because I can see that for the K matrix, if I go up, this K matrix over here, this off diagonal, they are not equal to 0. If it's not equal to 0, that means statically they are coupled. But if you look at your M matrix or mass matrix, they are not dynamically coupled. So sometimes we just say dynamically uncoupled. Yeah. So later on, we'll solve some questions. After you go for a break, we'll come back and look at work example 5.2. And we'll talk more about dynamically coupled. You can go for a break and be back in 5 minutes.